All right. So myself, Rajesh Day. I'm software engineer at GeekyAnts, and I'm working for like 1 year so far in GeekyAnts. Today, I'm going to talk about performance on React Native. It will be like a kind of mix with something like new things, something in details, and also with like very basic things that we do know, but sometimes maybe through the development, like we do kind of ignore it or like kind of push it backwards, and that can take a hit later at the development. So let's begin. So the first thing that we'd like to talk about, I think Shura also mentioned, is like like FlashList, right? Which is very optimized kind of component compared to scroll view that we get from React Native, and it's been quite the norm and like kind of like every one of us, like all developers, like use it throughout, right? But at the same time, while using FlashList, we have experienced some of the like perks at few scenarios. Recently, while I was working on a project, like I noticed that whenever we are kind of rendering a flat list starting with a non-zero index, then sometimes the component above it are not mounting all the time correctly. So that is kind of set up a drawback that we don't generally expect from flat list coming from like React Native. Then we start to kind of like explore other things, like what are the other solutions that can actually help us to go through this problem. Although like there are lots of there are lots of other things that we can implement on top of flatlist to kind of improve its performance a lot. Some of the props that I'd like to mention is like remove flipped subviews. So what it generally does is uh, like in a huge list, we like what scroll view does, like scroll view kind of like mount everything, right? But flash list does give a limit number of items mounted on the like on our app, and kind of remove everything which is not required. So we can pass certain values based on our requirements on the app, like how many items we want to keep rendered or mounted at the same time. Based on those values, like it's kind of unmounts the unnecessary components. So that improves like our performance on flat list a lot. So next come to the like flash list that Shiraz like earlier mentioned. So it's a kind of like new kind of component that is recently released, that is kind of like build and it's very simple. Like almost everyone like who has used flatlist can directly relate to it because its API structure is very similar, right? But I guess like I think you guys can notice like one prop over here, that is estimated time size, estimated item size. So what they are like our Shopify like flash list kind of ask us to kind of provide a certain value. If you can predict like as close to as the like the total number of elements, total number of items in the list, then it helps the flash list to kind of pre-calculate like how much it want to re-render or how much you want to like unmount or mount while scrolling fast. So and one more thing that we generally do like while developing React, that whenever we are like mapping over lots of data, we do provide key prop, right? And why do that? Like we say that we want to kind of tell React that like these are the unique set of elements, and even React throws some kind of like warning if you don't do that. But in flash list, we have to kind of remove it. So there is a very key difference that I want to mention between flat list and flash list. So what FlashList does, so FlashList does not rely on like unmounting the component that is way beyond your screen view. It keeps only one view, only one component like active, and it just alters the item prop. So while like it just don't like go through that mounting and unmounting processes that FlashList goes through. Instead, it just kind of like changing the new item in the same component that is being mounted. So it kind of does give lots of performance boost. So talking some kind of like figures that they kind of like are providing is we are getting lots of like FPS benefits in UI thread and JS thread. And I think like this is pretty impressive. Like for a large list, it's great. Moving on, one of the things like I think we even see in lots of the like articles that you can see like when we do kind of like on some kind of click handler, we declare like inline functions, right? And maybe we don't realize that, okay, like it's fine, like my component is not getting slow or something like that. But I've set like a quick example like to show how it actually affects. So over here we do have one like parent component called app, and in the child component we have a button. And when you are clicking on the button, so definitely we are like updating the state in the parent, so that definitely will parent the whole parent component, correct? But we can see in the console log that we are getting the log from both the parent as well as the child component. But from the UI point of view, you can see like there is no need for the child component to re-render again. Like it's just a static component, static UI component. We are not even passing the data to it, but yet it is rendering. So we have to be very careful, like when we are doing something like this in our projects where our child component can be very heavy. Then we must ensure that we do not pass like all inline functions as props. So what is the way out can be, right? So definitely what we can do is we can memorize the function using use callback, as well as if you need, like we can use memo the child function. So here's the kind of like same example, but here you can see as we're clicking on the update button, it's updating the state in the parent, but we are not getting extra re-render in the child component. So in case of heavy child component, this is great. Now it's come to like image optimization, right? So we do use lots of like assets, pngs, jpegs. Some of the assets like are kind of in local data, like in our local, and sometimes like it comes from the like some server url, right? And those do take time, sometimes like time, based on like how heavy they are and like how big they are. So our target would be to kind of use as small as possible. There are ways by which we can actually mention the size and the width, and also maybe if possible to kind of download only that resource from the server, if we have certain options on the server to kind of fetch specific like resolutions images. But if but beyond that, there are different ways we can do it. On web, we know that it's quite simple, right? Whenever we kind of fetch some assets, the assets is kind of like cached. That also depends on the headers that we do pass, and it also depends on the headers that how long that item will be cached on our like browser before requesting it again from the server. So on React Native, we can actually achieve something like that. There is another format which is like wasn't there much early back there. Like one is WebP. So what WebP does, like its quality is like almost as same as like JPEG, but its size is like very less, like around 25 to 30%, 34% like less size compared to JPEG and PNGs. It does support both lossless and lossy compression modes. And the good news is from iOS 14 and higher, it is available. Like Google had it like for a long time, but yeah, like on iOS, it's possible now. So coming back to like caching images, what we can do is there's another package called React Native Fast Image that we can use. So over here, what we can do is like we can like just pass the URL of the like whatever the image that we are going to show, and it does have certain like props which kind of leverage some more features to it. One is definitely the priority. Sometimes maybe we have a long list, and the chances are less that user will scroll to the end of it, and there might be some kind of like images that we are showing. But as we know beforehand that chances are likely less to kind of user to scroll past lots of few items, we can set the priority of those items to low, and can set higher priority to the items that will just show up on the screen when you are kind of going to the next page. It also supports a preload feature where before even like going to the component, when the loading starts, if we know that this is a set of images that is going to be the next pages, what we can do is we can preload these images. So what fast image will do, it will kind of fetch the data, it will cache it in the memory, and whenever user will go to the next page, it can instantly show it. So that improves the UX a lot. Yeah, we should talk about Hermes, and yeah, now like Hermes is kind of like would be like by default integrated on React Native, but I guess there are lots of projects like maybe some old projects that do not have Hermes and maybe we haven't activated it, but I think it's a great time like where we activate it and see its improvements. So what it does basically, right? Like so it's a like a JavaScript engine that is kind of like helps to kind of improve performance in like low end devices. So what Hermes does is like it it had included lots of like garbage collection procedures, and so which helps like kind of free up memory and also allocates for like virtual memory like virtual access to when it needs, and also release the memory when ways didn't need it. Sometimes we had faced earlier that due to this problem where our app cannot release the memory, so OS actually kill the app, right? But this will really help it. It also has included removed the JIT, that is a just-in-time compiler, to like ahead of time compiler. So earlier, I will show you like kind of graphical representation what it does. So you can see over here, the parsing and the compilation is kind of occurring like in the build time. That definitely will increase the build time a little bit, but will reap up the benefit when we're like launching the app. So after install, when like user will like launch the app, it will already have everything converted in bytecode and parsed, right? So it kind of like improve the like app starting time, the boot time like a lot. So here we can see that with like a stock React Native app, like the TTI kind of like increased, and like APK size has been decreased, and also memory utilization has decreased a lot. Yeah, coming back to style sheet. So over here, it's not too obvious. Like we do declare styles like this, right? Apparently, it might seem that hey, like what's wrong over here, right? We can declare styles like this, but the thing is that we need to kind of know that whenever we're passing like objects and arrays in the props, so it is kind of like uh, reinitializing, like I mean it's kind of recreating the objects on each renders, so that might take a hit a little bit on our performance. Instead, what we can do is you can use the style sheet from React Native, create a like object and use that reference in our style props. Yeah, there is one use case where maybe we need to depend on some kind of user data or some kind of like navigation state based on which we want to like change the styles. In those cases, yes, we have to use some conditions and rely on state. Then we cannot always use reference. But most of the cases, I think like it's pretty much like very easy to kind of fetch everything from like get everything from style sheet. Yeah. So we like when we generate build for like both iOS and like Android, we have noticed that this app size is an issue on Android, right? So there are ways by which we can actually reduce the app size a lot. One of them is like using app bundle. So earlier, like what is to do, like maybe we used to just create one universal APK that will include all the architectures, all CPU architectures, and that's why it becomes huge, right? And you should like upload that APK on Play Store. But now, what we can instead, what we can do is we can use like app bundle, and we can upload that app bundle. So app bundle will not include all those architectures, but those architectures will be integrated on their like Play Store end. So the size can be like reduced, can be reduced drastically. Like with an universal APK, I think it takes about like with a very like stock React Native app would be like around 25 MB, and like with just creating an APK, you can see like we can reduce it back to like 3 MB. So that's a like huge benefit, and we can achieve that very easily just using this command. It's just simple as that, and we will just will it will generate a .av file, and we can upload that .av file to in Play Store. Another is like resource shrinking that we can do. What it will do, like it will kind of like minimize and like kind of remove unnecessary resources from our app. We can like just include the string resource true on our like app builder gradle. and it will just kind of process that during our build time. Enable proguard. So what proguard does is like it kind of obfuscate sometimes like we would like to kind of prevent or make things difficult for anybody who's trying to like reverse engineer our code. Uh, but it also kind of remove some of the like code that is not mapped and that is not being used in our code base. So this is the like a proguard profile where we cannot just remove everything. Like we cannot allow to kind of proguard to obfuscate everything in our code base. So some of the things that sometimes like we are using like Hermes, JNI, and those packages will mention that these are the rules that we need to kind of set in proguard to prevent obfuscate those files. Otherwise, something might break up. So this is one of the things like we need to kind of take care of it without just enabling a proguard directly. And so coming back now, what things like when you kind of like develop one like app, we got some features, we released it, and maybe our client is saying that okay, like our app size is like too large, and then we don't know like what is kind of taking so much of space, right? So we can use some kind of like a bundle visualizer. One of the like great tool is like React Native bundle visualizer, what we can use. So we give the bundle and we kind of like give the bundle and it will analyze it and it will give a kind of GUI where we can see which package is taking how much amount of space. So that really helps you kind of understand if you have included a new package recently and that is taking up or like adding up extra space or kind of taking up extra space in your like final bundle. And maybe you can work on that or like remove or find some alternatives to that like, heavy package like that is being included on our project. Last but not the least, that this one will be like console log. I guess still like most of us like use console log. Like yeah, it is recommended to kind of use some kind of debug tools or like debug points. But yeah, like sometimes we do like quickly put console log and check like what is going on, and we do tend to like forget to kind of remove it before pushing the code sometimes, right? There are ESLint rules that kind of like keep us warning to kind of remove it, but I guess the best way would be to kind of go with a simple Babel plugin. And this Babel plugin is just kind of like very easy to set up. Like you just install it, just add the plugin in your Babel config and done. So what it will do, like it will automatically remove all your console logs from the production build. And like I think then we can get the benefit of both like both the world. And coming back to performance monitoring, there are different tools available on the market. One is like Sentry, Firebase performance monitoring, and some other tool like Instabug. So why performance monitoring is important? See, I would say that we must know like how our like in a like a big app, it's not always possible to kind of go through each one of the like each of the screens to kind of see any kind of visual differences. But if we are using any kind of like monitoring tools, then it will help us to kind of understand like why we are kind of like why some of the screens are maybe lagging or kind of dropping maybe some UI like some UI threads performance, and this kind of give us the insight and help us to kind of act on it properly. I will show kind of like a report that I got. So this is a screenshot from Firebase, Firebase performance tools. Over here, you can see one of our like API response time that has been become slow in like maybe last 7 days, right? And it shows that it has gone down by like 4% slower. So now, with the benefits of having this kind of visualizing tool, we can really understand where exactly our flaw is. Like, is it occurring on our front end or is it on your coming from the back end? Maybe it's taking time to kind of fetch the data from the server. So I guess we should always like use some kind of performance monitoring tools to kind of have better insights and then act on it. Yeah, I think that's all from my end.